Since this one is going to be a multiplication and a division, we only have to use that equation once, like in that previous slide. So we have 1.76 times 1.89 divided by 0.59. If I was just to do the math, so 1.76 times 1.89 divided by 0.59, that gives us this answer, 5.64. So that's that first part. Now we just got to figure out what is the, what is the uncertainty? So that equation is going to look something like this, where it's EY divided by Y. EY is going to be the uncertainty. Y is going to be the answer. All right, so I'll erase that real quick so I can write it all out. So that's going to be the square root of the uncertainty of the first value, 0.03, divided by 1.76 squared, plus the uncertainty of the second value, divided by 1.89 squared, plus the uncertainty of the third value. Just remember that because you have multiplication and division, we can all squeeze this into one equation by itself. So it's a good thing that everything is multiplication and division. When I do the math for this, 0.03939 is equal, let me just erase this, to the uncertainty that we're looking for divided by the answer, 5.64. So I need to go one step further and divide it by 5.64 on both sides, so that will cancel. So when I do that, I get my uncertainty is equal to 0.222. So my answer is 5.64 plus or minus 0.222. But technically this is not written to the correct sig figs. The first non-zero number in your uncertainty is going to be the same decimal place as your last number in your answer. So just one decimal place. So when I rewrite this, 5.6, I'm not going to round because it's a 4 is the next number, plus or minus 0.2. This next problem is a little trickier because this top has a subtraction and the bottom has division. So we need to actually separate this. So I'm going to rewrite this to where the top is by itself. Sorry, I'll include the uncertainties. So 1.76 minus 0.59 is equal to 1.17. The uncertainty is just going to be equal to the square root of the uncertainties squared, and that is 0.036. So that's, I'm going to move this number to the answer. Now, if this was the final answer, I would definitely account for those sig figs, but since it's not, I'm just going to leave it as is. So on the next slide, I'm going to rewrite this to 1.17 plus or minus 0.036 divided by 1.89 plus or minus 0.02. So when I do that, I get this answer, 0.619. But now let's do the uncertainty. EY divided by Y is equal to the square root of 0.036 divided by 1.17 squared plus 0.02 divided by 1.89 squared. So on the right-hand side, I get 0.0325, but that's not going to be in my uncertainty because I'm going to move this down real quick. Our uncertainty divided by our answer, 0.619, is equal to that number. So I'm going to multiply 0.619 on both sides, so that will cancel, and our uncertainty is what's left over, which is 0.0201. So if I'm asked what is this answer in sig figs, our answer is 0.619 and our uncertainty is 0.0201. But that last decimal place, sorry, the first non-digit number in the uncertainty is the last decimal place or last number in the answer. So it's going to be 0.62 plus or minus 0.02. I really want you to get comfortable with this table because this is going to be a lifesaver for these types of problems, because technically every type of arithmetic will require an uncertainty type of math, and we're going to have to practice all of it. So we've done these so far, but what happens if your equation looks like this, an anti-log? Or sorry, that's not an anti-log. This is an anti-log, or a logarithm, or a natural log, or e to the power of. So you're going to be thrown a lot of math, and you can always use your calculator to find your answer, but how do you find your uncertainty? Well, you'll have to use these equations, and we're going to practice using them. I don't expect you to have them memorized, but you need to be able to use them.